My name is Iris Classon. I'm a Microsoft MVP since 2013. I believe it's 2013, might be 2012. I don't remember. It's been a long time. I'm getting old too. I'm an author and a speaker, and I'm a software developer at Greenbyte. And I'm also a mom to Luke, who's 2 years old. And that photo was taken when I believe he was 3 months old, and I was speaking at Tech Days. I'm still just as tired. Fun fact, I'm a clinical dietitian and personal trainer. I will be doing none of that during this presentation, because this presentation is going to be all about multi-tenancy, which is something I really like. So multi-tenancy is an architecture. It's an architecture in which a single instance of software application serves multiple customers, and each customer is then referred to a tenant. Now, I say single instance of a software. It doesn't have to be a single instance of a software. As you can see in this nice drawing here, it's actually a cluster. But I'll get back to this later. But this is what this presentation is about. And I got the idea for this presentation a couple of weeks ago. We have bi-yearly or yearly hackathon, which we call TEFCA at Greenbyte, the event formerly known as the hackathon. And during this event, we usually write code, and there are a few non-engineers that do other things and not write code. But my project was, I'd like to see if we could take a part of this massive system called Greenbyte and make it multi-tenant for a variety of reasons, which I'm going to cover later on. So we had 2 days to do this, and since this was remote, we've been working remote for over a year. Actually, I've been working remote since I started there. I've only been to the office for 3 weeks before we started working from home due to the pandemic. So we only have 2 days, and that's not a lot of time. And since it's remote, it means that although it says 2 a.m., there are very few of our colleagues would actually work around the clock on their hackathon project. So not a lot of time, but we had really, really big ambitions. So we wanted to take a part of the platform and the web API, make it multi-tenant, shove it in a container, Linux, migrate it to .NET 5, add auto scaling, and also add data integrity and load tests. So we had a lot of ambitions, and we actually succeeded with all of them. But the only thing that actually really matters for this presentation is the multi-tenant web API part of it. So as you can see on the date, this was in February, and not long after was asked, Dan contacted me and said, "What do you want to? What's your session going to be about at Code Camp?" And I usually talk about Azure and the cognitive services because I'm very excited about them, or migrated to latest version of ASP.NET Core. But since the hackathon, I noticed that there's been a growing interest for multi-tenancy. I mean, it's been around for a long time, but now we're starting to see these really old legacy applications getting a little bit more cloud mature and ready to take a look at alternatives. In particularly, there can be some cost saving involved. And although most developers are probably familiar with the concept of multi-tenancy, not everybody knows the details around it. And therefore, I want to do a session which breaks down what multi-tenancy is, and with some comparison. And the comparisons I'm going to use, I'm going to be talking about 2 real-world examples. And I think that's really important to get an understanding, and not just a diagram like the one I showed you earlier. I'm going to talk about the why, pros and cons, obviously, and I'm going to back that up with examples from my current workplace and also my previous workplace. And then I'm also going to do this using drawings. This is a level intro 100, just to set your expectation right. And hopefully I can manage to stick to 100. We might go up to 200 bits and pieces. I wasn't planning on showing any code because there's not a lot of time and there's a lot of talking I need to get done. I did, however, just put together a very quick example, just so there is some code on the screen, and hopefully there'll be time to take a look at that as well. Just going to have a drink. All right, so multi-tenancy. Architecture in which a single instance of software application serves multiple customers. Now, as you can see in this drawing I made here, So each customer will be navigating to a site. So I'm going to use a web application as an example in this slide, but it could be just a straight out service or just an API or whatever. Actually, multi-tenancy doesn't have to be software. It could be infrastructure. It could be different things. However, usually when people talk about multi-tenancy, it's usually referring to software as a service. And that's what I'm going to use for this example, because that's where I have my experience. I'm not an expert, but I do have a lot of experience with this. So each customer will visit the site, and the way they perceive it, it's like they have their own version of the application. But actually what happens is they all use the same application or the same set of applications, the same cluster. Usually when you set something like this up, if you want to do it properly, you probably want to have a load balancer if you have a lot of traffic coming in and you want to make sure that you have enough redundancy in case something happens. So you have a load balancer, then you have a cluster, and then you have storage. So you can see the storage, I have I drew one SQL server, but it's obviously going to be multiple. That's also a cluster, and each tenant has a database. There are different models. I'm going to talk about the different models, but since I do prefer data isolation, I've used the model where each tenant has their own database instead of sharing databases, for example. So how does this compare to single tenancy? Well, let's take a look. So using sort of the same concept with 3 tenants and a load balancer, you have, for example, each cloud represents a virtual server. So that's a virtual machine, 3 of them. And on each one, you have an application for each of the customer. So that means that for each customer, you'll have to deploy at least 1 application. And since we have 3 servers, because we want to have redundancy and all that, then we end up with having 3 per customer. It doesn't look too bad. Doesn't look too different from multi-tenancy, but there's a whole lot more resources, not only to manage, but also to pay for. And that's where Greenbyte comes in. So welcome to Greenbyte. This is a very, very, very simplified architectural drawing of Greenbyte and all of its different bits and pieces. There's way more to it, but I've tried to sort of simplify the drawing as much as possible. So if we start in the top right corner, where you see the wind turbines and what's supposed to be solar panels, this is where it all begins. Because what Greenbyte does, it's basically we are the data hub for renewable energy. What we do is we gather all the data from all these devices, and then we aggregate and calculate, we extract, and we not manipulate the data, but we work with the data to let the customer know if everything is working as intended, how much energy is produced, what is the potential in producing energy, what types of curtailments do you have, and a whole lot more. We're talking about millions and millions and millions of data points per customer. It's a lot of work, and it's a very, very big system. So when the data comes in, it goes through our so-called ingestion applications, because there is no standard for sending this type of data, at least not yet, as far as I know. So I think we have about 30 ingestion applications. The data could be in the format of OData, it could be XML, it could be CVS, or it could be some really funky custom type of format. So we have the ingestion applications that grab this data, make it to a sort of normalized format, shove it on a Kinesis stream on AWS, Lambdas, grab the incoming data and sends it to places. For some customers, we put it in a queue, and it also has a dedicated queue that belongs to it, but I'm not going to cover that. And it will make copies of the real-time data, and this data is going to be copied to servers that clients can access. So this is an extra feature we call data warehouse that some of our customers have, and this is a lot of data. That's why we don't do it with all of them. And afterwards, besides that, the data goes in the middle, as you can see, to some servers. We have a lot of them, SQL servers, or not SQL, MySQL. And then from there on, we have our platform, which is basically a distributed monolith. It used to be a monolith. We've broken out some pieces, but there's still a lot of dependencies. So we refer to it as a distributed monolith. And it does a lot of things. So we have also executable applications that would handle things such as alerts and exports and calculations. And then we have some self-standing microservices like predict recommendations, benchmarking, and a mirror application that belongs to the research team, the data scientists we have at Greenbyte. We have some, and we have some mobile apps, Apple, Android. These are just wrappers around our browser version, basically. And that's the web application with React and Webpack and a bunch of stuff I do not understand as a backend developer. So it's a lot. Now, parts of this system are installed per customer. So each customer gets 3 copies of it, but not all of it. For example, the export and the calculation applications, those are tenant agnostic. They will just, they basically work as, I don't know if you've worked with Hangfire or similar job service types of applications. They just wait for a job, and when there is a job, they will start it, and that's how they work. So they're not really dependent on the tenant. They just see if there's a new job lined up in queue for them. Now, the platform application has a part that is the web API, and that's something that we started breaking out a while ago. And this web API seems to be the perfect place to try to do a multi-tenancy application because it is slightly independent from the rest. And also because it's just a web API, that means that we only are concerned with the authentication method that we use for the web API, which in this case is API keys. So this is the Greenbyte platform, very simplified. So what exactly is the problem? Now, if you look at that pink little cloud web API, how many instances of it do you think we have? Well, we have a lot of instances. I believe we have approximately 120 customers, and that means it's 360 API services. And that is a lot to manage. And suddenly it makes sense if we could actually just have a cluster of services that could be shared among the customers instead of deploying for each of them. Because not only is this quite expensive, and also means that we cannot guarantee the same path for each customer, even though we use a nice deployment service such as Octopus. It also means this. So our release process takes about half a week. It's long because there are a lot of things that need to be synced, and we are very thorough with our testing. So we spend days just doing a lot of manual testing because there are a lot of things that cannot be automated, and the exploratory testing and regression tests are immensely important. However, if you just look at the deployment time, this is a screenshot from Octopus Deploy. There's a lot of waiting in between, and there's a lot of waiting for everything to finish. So this takes 2 to 3 hours. And imagine if you have to do a rollback, that's going to be the same amount of time. And the same thing goes for doing patches and so on. So the deployment is also a big problem for us. And one of the things that we would improve greatly if we had a multi-tenancy system. So 2 to 3 hours, this is just for the web API. And then we have the platform, we have the microservices, and then we have everything else, the different CDK stacks that make up our Kinesis streams and lambdas and streams and so on. So where do you start? Well, it's a bit too much to take it all, but you can start with the web API, right? So that was our idea. But how exactly is this done? All right, I'm going to show you quickly how multi-tenancy works. And the reason why I was going to do this drawing was because it's really language agnostic. You don't have to use .NET or C# for this. The principle is basically the same. So I'm going to try to do some drawing here. This is a Blackboard application I did 8 years ago, so I'm surprised it still works. So say you have one customer. So I'm just going to use I'm going to draw 2 of them. And this is tenant A, and this is tenant B. say tenant B makes a request. So again, we use a web API example for this one, to site.com. And downwards here, this is going to be the request pipeline. So that's request. So what we do, so there are a few ways you can do this. First of all, when the request comes in, you need to identify the tenant. And there are a few ways you can do this. You can use the subdomain. You can use a part of the path, or maybe you even allow custom domains. We don't use custom domains, we use a subdomain, and I do believe this is the most common multi-tenancy model for SaaS applications. So you grab this from the context, and once you have this is the tenant, that's where you want to do a mapping. So you usually have some sort of global lookup table. And this is really important that this is secure. So you don't want to have everything in clear text. You want to have it encrypted, and you preferably also want to have a key vault to store your secrets. For example, Azure Key Vault is pretty awesome, but there are a lot of alternatives and ways you can do this. But it's immensely important that this is done in a secure manner. And also further down this pipeline, I'm going to show you here authentication. So this is just the part where we find out which tenant it is and set the context. So we do a mapping, and once we have the mapping, we have the tenant context, tenant B context. And I say context because this could be, for example, database context. And when you fetch the data then, further down in the request, when you get the data, you're going to use this tenant context to get the data for the right tenant. Although there is obviously one really important piece missing here, and that is authentication. So you need to have a way to authenticate and then also authorize. So you usually have some form of authentication here further down the line, but you do need a context to authenticate because you want to go against the right user table. And for example, if it's an API key, a hash API key, you grab the context and then you look it up in the API key table, verify it's correct, and then you fetch the data. If it's a website, you usually want to create a nice little secure cookie and store the information as well. So you can use that on subsequent requests, and you can check the authorization header. So this is simplified how it works, and it's, as I said, language agnostic. However, I did want to show just a little example in code. So I have implemented the most naive example I could think of. So this is not something you want to copy and paste. So let me repeat that. This is not something you want to copy and paste. So we have our get stuff controller, and the get stuff controller has this horrible and direct reliance on this get stuff repository, but that's okay. It's an example, so we can live with that. So how exactly does this work? I'm using Postman here to test the requests, doing one request against tenant A. You might not be able to see it because it's quite small, but it says tenant A.local. And then it fetches stuff for tenant A. And if I'm using tenant B, it will fetch stuff for tenant B. All right. So how exactly does this work? I'm honestly, this example took me 10 minutes to put together. So this is very naive implementation, but I wanted to show you something, and I can't show you production code, unfortunately. So where it all happens, I'm going to show you here in the tenant context. So you usually want to have a class that is going to grab the part, you know, when I showed you here, where you grab the part of the URL that you're interested in that indicates which tenant it is. So it could be subdomain, it could be the path, it could be custom domain, it could also be a header. So it could also be that they have to send it in the header. So that's also an alternative. Haven't seen that a lot though, but it is definitely another way you can do it. So here I'm just very cheekily just grabbing it, and the reason why it says host is unfortunately the HTTP request host may include the port, so you have to do host and then do a split, but Yeah, never mind. So I'm grabbing the subdomain. Obviously, you want to do a few things here. You want to double check that it actually exists. And then I have a tenant store. And this tenant store here, I've just hard-coded the different tenants in code, but this is where you will have your global mapping table. And this global mapping table is probably going to contain extremely sensitive information, and you have to really make sure that nobody can access it and you never, ever fetch the wrong data. So the tenant store, let's take a look at the tenant store. This is the actual store, nothing to brag about, but nonetheless, it just grabs the tenant using the identifier. And what happens in the get stuff repository, it has a dependency on this tenant context. I'm using dependency injection here. And usually what I do when I set something like this up is I will have a database context, and this database context will automatically know how to set up the right tenant context for the database. So and you have to do this very, very, very early in the dependency graph, because the later you do it, the easier it is to get it wrong. And this here just basically fetches the data for the right client. So we're just sort of pretending we're actually just returning a string. And that's it. Now, this doesn't have any authentication and authorization. And this is a very, very simple implementation. But I just wanted to have some code to match the drawing I just did in terms of how multi-tenancy works. And if you're wondering how I'm testing this out, I'm running the application using Kestrel. And in PowerShell, I've used there's PS host, I think it's called, the module. It's just an easy way to add entries to your host file. And beforehand, I just added mapping tenant a.local maps to my local IP and so on. And that's how I can test using tenant b and tenant a.local. So yeah, that's it. Now let's go back to, I'm going to clear this one in case I need it. All right, so I covered how. So I used to work at this place called Construct, and I might actually grab the Blackboard application. So I started at Construct many years ago. I worked there for 5 years. Ooh, I don't know what happened to my tablet here. Just got the biggest mouse pointer ever. But yeah, I worked at Construct for 4.5 years, almost 5 years. And one of the things I was tasked with was taking the application and doing two things. So it's not an application, it's a system. And Construct, I'm just going to write K for Construct, and this huge mouse pointer is very, very distracting. And it used to be an on-premise installation. On-premise means that the clients install the system on their own servers. And I guess when you're a startup, because Construct was a startup, that's completely fine. And also if you're not a startup, but that's how they started. But that didn't scale very well, because soon they had clients who said, well, customers who said, well, we would like you to host it because we don't want to deal with maintenance and infrastructure and all that, because that's expensive and we don't have the knowledge or ability to do so. So we had on-premise, and then we also had our own cloud, local cloud. Local cloud, yeah. So these were the two things we had. This here, this was first a server in a closet. Very quickly, this server was moved to a server on Azure, which is a great improvement. But it was just one server. So when I started, I was tasked with two things. One, take Construct and move it to the cloud, all of the different services, and also make it a multi-tenancy system. And that also means with ability to scale, blue-green deployments, and so on. And that also entailed that I had to build a pipeline, which is very poorly drawn underneath there. because this was done by copy paste. So that's not something you really want to do. But this was very, 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 very early when the product only had a couple of customers. So that's what I had to do. So I took Construct and other services, there are about 12 of them, and used something called cloud services at the time, and put everything up on Azure. And then I made the code multi-tenant, very similar to the diagram or the drawing I showed you earlier and the code I showed you, but with a bit more security in mind. And the end result was something like this. So you have the customers, they will go to blah, 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 construct.net, the web application. We would authenticate, set the JIT cookie, and then we would use that for subsequent requests to verify which tenant it is and also which user and other claims we saved in the cookie. And we actually never got around to using Azure Key Vault, but we did have a similar setup with certificates to make sure that we wouldn't actually, so we could very easily change our keys in case something happened. And we also used Azure file storage and a few more things. A very nice setup that worked really well for Construct. Now I talked about that they had to be on-premise as well, and that's something I found really interesting because I'm not sure how common that is with multi-tenancy applications, but we had to be able to support on-premise as well. And what I first did, and that was actually not a very good solution, was that in the code, there were two paths that you could go. So when you came in the code, you could either be on-prem or multi-tenant. And I actually used conditional compilation for this. So depending on how you compiled the system, it would compile on-premise or multi-tenancy. However, one other clever developer that started a little bit later actually came to the conclusion that we actually don't need to have a separate path on-premise. We can install it as a multi-tenancy system on the customer servers because we just let it be just one client or one tenant in the tenant database, and it will work the exact same way, and it wouldn't really require a whole lot more resources. But we did have support for both on-premise and multi-tenancy. I wanted to bring this as a part of the example to show you that you can cater for different scenarios. Although ideally you would force every client to use the cloud version, you might actually be stuck with some clients that have to have an on-premise solution. And the on-premise solution was for the migration office. I think that's the correct translation, due to data security and so on, and also want to have the data within the Swedish region. And at the time, I don't believe that Azure offered anything more specific than West Europe. I do believe they might be doing that now. And we also had our own cloud, which we moved to Azure. And later, we actually decided to use a local cloud provider instead. And this is how we convinced our on-premise customers to join us using the local cloud provider instead. So with Construct, we just took all of it and made all of it multi-tenant, and that worked really well. However, we don't have to do that at Greenbyte because some things are already tenant agnostic. But at the same time, as you saw in the diagram, Greenbyte is a very complex system. It's been around for like 10 years or something. So we can't just take all of the platform, but we could take the web API. So the final solution looked like this. It's a bit more fancy because we threw in more things. We actually didn't have a load balancer at Construct. I don't know if they have that now. I didn't know anything about load balancers back then. I do now. So this is the setup we had using not just one, several load balancers, using Fargate for containers and the APIs into the container, Linux containers, and yeah, having a cluster that all the customers could share. And the cost we actually saved doing this, we calculated the cost. And so you need to see, I can't say the exact number. I don't think I'm supposed to share finances. But it was approximately 1/5 And we made sure we had a really good cluster. So we probably overestimated how much we needed for the multi-tenancy, but it was a significant cost reduction. And also the deployment pipeline, it would probably take us 20 minutes to deploy or something instead of 2-3 hours. I'm not even sure if it would take 20 minutes, but it would still take a couple of minutes because you want to deploy like a set to test first and so on. But it was a big difference. So what exactly is the plan then with the web API? It's not in production yet. Why am I even talking about it then? The reason why I wanted to bring forward this example is because the Greenbyte multi-tenant web API example is really interesting because this is a really complex system that's been around for a while. And there's a lot of dependencies and interactions between the services. So we can't just take all of it, as I mentioned earlier. However, we want to start and we want to do it somewhere. And the best way to do it is to take a smaller piece and make it multi-tenant and then put it in your pipeline. So this pipeline is actually the pipeline. I made this drawing for Construct, but the pipeline for Greenbyte is very similar, except we don't have the on-premise, as you can see at the bottom there. A typical pipeline, you have a repository, you have like a build service such as TeamCity, like, oh, something has changed, got to run the different build steps and tests. We're going to create our packages, Octopus or deployment service of any sort, take the packages and send it to the different environments. We do some testing, QA, user acceptance testing, maybe A/B testing, I don't know, and then deploy. So the plan is with the web API, and this is actually already happening, is we're going to have a separate branch for the multi-tenant version. So that's going to keep rebasing, and the code we changed isn't code that is often changed, so we don't expect any conflicts. And we're going to deploy to a separate QA environment where we'll be testing. And we're going to do this for a while because we want to make sure that we collect a lot of data, because this is not something you do overnight. So the plan is to take some customers that like to be beta trackers, that like to try things that are newly released, and that like to give feedback. We have a lot of those customers and we really appreciate them, and let them start using the multi-tenant web API and collect a lot of data, because that's very important. And little by little, we'll see if we have any problems and how we can manage those. So it all sounds really awesome. So to summarize, what are the pros of multi-tenancy applications? For us, or my experience, the biggest thing has definitely been cost saving, and that is really important when you have to be able to scale. So it's costs. The one that I'm personally most excited about is a very simplified or much faster, more efficient pipeline for deploying. And this also means for rollbacks and patches and so on. You also make sure that each customer has the same path, which is really nice. But that also means that you need to be extra careful with logging. And that also means that you have to treat logging a little bit differently, and also data collection. Since obviously they're sharing services, you're not going to get the per customer CPU usage and network traffic, not out of the box anyway. So you need to think about all those things. So that brings me to some of the downsides. The downsides is, since you're using the same resources, this is where all the problems are. You're using the same resources. So one of the problem is that you don't have the same level of isolation as you have if you have, for example, one server per client, or if you have one application pool per client or whatever. These are fairly straightforward isolations that you can trust. But with multi-tenancy applications, you don't have that. So you need to try to create some sort of isolation as best as you can within this context. And that means encrypting everything that is very sensitive, verifying having data integrity tests. These are quite important. You also want to do data integrity tests using load tests that are run in parallel, because you don't want to make sure nothing funky happens if you have 100 clients making 1,000 requests at the same time within a very short amount of time. So you need to have all these things. Also, logging gets not tricky, but it becomes much more, it's different. And also, for example, if you have IS logging, and if you usually integrate that to some, hopefully you're using unified logging. Seems like most people do that today. So take all the logging and you shove it in one place. It gets a little bit more tricky to separate the log entries for the different tenants, depending on the source. And also it comes to network and CPU and all those metrics that are equally important. You need to figure out a good way to make those tenants aware. For logging, we've actually been using Datadog now. I'm quite happy with that. At Construct, we used application insights from Microsoft Azure, which I am a massive fan of. Datadog is okay. I haven't gotten used to it, and it's not quite the same thing as application insights, but those are perfectly fine alternatives, and there is a whole lot more that you can use. But the most important thing you need to think about with multi-tenancy applications is security. And you don't want to build something fragile from the start. And I've seen this happen, or I've heard this happen different places. Would be quite rude of me to give an example, but this can very easily happen. So encrypt, hash, separate, use a key vault, use certificates, and all those goodies, and don't have like an admin login with password 123. It was on the news today. Was a site that was hacked, and their admin root account was password 123. I am not joking. This is like the third time this has happened in 2 months. So yeah, security is immensely important. I have not shown you how we have implemented this at Greenbyte and Construct, because I'd rather not share that data, that information, since it is sensitive, but it is very important. All in all, I'd say multi-tenancy is the way to go if you if you have a lot of tenants and the benefits are really good. But you don't have to do it. If you just have a couple of tenants, maybe just keep it per tenant, why not? If you have any questions, I'll be happy to try to answer them. I am by no means any expert, but I've been doing this a lot. Thank you very much. And you can find me on Twitter, Iris Classon, and whatever social media, except TikTok. I'm too old for that. I'm not on TikTok or Snapshot. I don't know, something.
Snapshot. We agree. Okay, we agree. Yeah, right. So thank you so much for the talk. So you made multi-tenancy seem easy, while it's not. I mean, it's a difficult architectural problem to solve, right? But you made it look easy with your enthusiasm.
Well, it's not. I honestly, I don't find it that difficult, but it is easy to make mistakes. But it's the concept itself is not that difficult. And I was honestly, I was confident that we would be able to do everything in, what was it, 12 hours we had at Greenbyte, and we did. And we have something that is ready to actually be tested. So it is absolutely possible, but it also depends on how much knowledge you have beforehand. So we have a CAT team, an infrastructure team, that they know every bit of setting things up securely and so on, and then we'll make sure to manage all that on AWS, and that's not really my area. So it does depend on what type of resources you have within your team, what type of knowledge it is. because you can't just copy and paste these code examples like the one I did and chuck it in the code and go like, yeah, this is going to be great. Because if you serve up the wrong data for the wrong tenant, oh boy, you can't.
Not sorry to interrupt, but now that you're mentioning that, there's a question from the audience saying, how can you assure that you never fetch the wrong data from the tenant store?
You have to try to isolate it as best as possible. And I forgot to cover the different models for in terms of tenant storage. But I know some will actually say, share databases and use a schema instead. I would never do that. I'm trying to think of a reason why you would do that, but I can't. Based on my experience, I haven't really worked with the system where I would want to share the same database among tenants, unless it was for really, really unimportant information. Of course, you have the most sensitive thing you have, that is the global lookup table, because that's where you're going to have the connection strings to all the tenants. And that's the one you need to guard with your life, because if that gets out, then you're goners.
Indeed.
And probably avoid like command line, I don't know, processes that take like target and source, right? Because if you swapped up, because I've heard a terrible story from a big vendor, technology vendor, that was using such a command. And of course, they swapped the two arguments. So, well, you can imagine what happened with the data between the two databases.
Yeah. Yeah, I've also seen implementations where they've done they fetch the tenant out of the URL, and they use that for subsequent requests, but they don't do any authentication. So that means you could replay the same one, you just send in a different tenant. And it seems like such a mistake nobody would make. But if you have a tired developer and a little bit of copy and paste, and you're rushed and you have to get it out, and you don't have data integrity tests and so on, then, and also the data integrity test, there are so many ways you can do this. So one of the things that we do is we will set on logging on our MySQL service and verify that when we do requests, only the correct tenant is accessed the correct database. So obviously you can't do that in production because that's going to be a very huge logs. But we're going to, for a period of time, log absolutely everything and make sure that everything matches up.
I'm not sure if you mentioned that, but have you considered doing like totally separating the infrastructures? So you cannot call other database or structures by design.
Yeah, our databases are quite central in our system, and I think that's very common for a lot of monolithic applications, distributed or not, and that makes it a little bit difficult to separate. So the example I used also, you also want, and I also want to mention that in terms of code, when you register your services, so I use dependency injection. I didn't show the example where I actually registered the services. What you want to do is you want to have set a tenant on the container level. So you can do it directly on the dependency, such as the tenant context, but you can also set on the container level, and that gives at least a little bit more isolation.
That's cool. Let me just read one of the messages from the chat about your mood and vibe. Brilliant. So great presentation, Iris. You have a good vibe, and you've managed to have my attention for the entire presentation.
Oh, that's awesome. I'm so out of breath though. I have a microphone, but I'm like yelling in the microphone. I don't know why. It's like when my grandma calls me from Romania, she will like literally yell, like she has to yell across the continent
because
to reach me.
It's far away, of course. It's far.
I love the drawings too. So the fact that you started drawing and while explaining things, it was awesome.
Thank you. The Blackboard app is actually so old that I'm not using the ink canvas in WPF. It's actually like manually plotting the lines. Nice. It's really old, but I like it. So yeah.
Okay, I think we have time for just one more. I have to do it in 1 minute. So what happens when a cluster goes down or crashes? All of the tenants are locked out of their data.
I've actually never experienced. So the whole idea with the cluster is that it's not supposed to go down, because if you have clusters of clusters, I'm not sure how that works. This is a little bit beyond my area of knowledge. So wish I had an answer for that. But as long as you host in the cloud, if something goes down and you don't have a plan for that, unfortunately, you'll just have to wait until it comes back up. And I was a very early adopter of Azure, and those of you who joined me on that journey, you know, there were a few things in the beginning where when you weren't able to access your machines, even though you had failovers and so on. So. But it happens less. And also make sure you read your service level agreement and make sure that it matches what you give in your service level agreement. So never promise 100% uptime because your cloud provider don't.
Exactly. And to end this again in high spirits, there's another remark just popped out. I loved your presentation as well. We'll listen to it a couple of more times for sure. So,
and applause.
Yeah, thank you.
Thanks again for being with us. Camp.
Thank you. Mulțumesc.